Hi, GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
All right, welcome everybody. My name is Pete LePage. I'm a developer advocate with the Google Chrome team here at Google. I guess I said Google a few times. It's Google on the mind today. And with me today, joining from London, we have Paul Lewis.
Paul Lewis.
Mr.
Yes.
Lewis, how are you doing today?
I'm very good, thank you. Yeah, as you say, live from London, so yeah, all good.
Excellent. Well, so last week we had a hackathon back in Mountain View that we were both there for, and we got to play with some interesting hardware. We did some kind of neat things. I sort of alluded to it in our hangout last week. But one of the big things that I think you and Paul Kinlan did a couple days before was to sit down and start doing a little bit of hacking on one of the Parrot AR drones, right?
Absolutely, yeah. So Chrome has the sockets API, and we knew that this drone, communicated over UDP. So what we wanted to do is find out, how difficult or how easy it would be to actually, get Chrome through a Chrome app talking to the drone. So it's exactly right. A couple of days before the hackathon, as you say, Paul Kinlan and I sat down with the documentation and started hacking away.
All right. Well, so we recorded some video of us playing with this thing the couple days before the hangout. Let's take a quick look at that video right now. All right. So we didn't put any audio into the video, but you can see the drone flying around. Now you hooked it up via a gamepad. So the gamepad is actually controlling the drone. Gamepad's hooked into Chrome, and then the Chrome's connected via Wi-Fi to the drone, and the drone goes flying around. Isn't that
that's pretty much it? And what we're going to do is we'll step through and talk through each of those bits today.
All right. So we'll take. I think the video has just a little bit more to it. We'll take one more quick sec. We kind of had a lot of fun. We kind of crashed the drone, I don't know, 300 or 400 times. We ended up having people run away from it. It was kind of fun. And in fact, I think we hit each other with it a few times accidentally. It's pretty easy to fly once you sort of get the hang of it, but it took us a little bit to get the hang of it. So the video's done, so let's sort of jump in and take a look at some of the things that went on. So do you want to start just sort of explaining how you started and what you were thinking about as you were working on this?
Absolutely. Okay, so I don't know if you want to, if you still got me on camera. This is the drone.
Yep.
Hey, this thing is absolutely brilliant. And we had one of those. We have a standard gamepad. And as we said in the intro, the Gamepad API is what we use to get input. But actually, we didn't start with that. What we started with was the SDK and the documentation. And the team at Parrot actually have a PDF and a fully fledged C library that you can go and look at that will explain to you exactly what you need to communicate and how and all the rest of it to the drone. So that's what we started with. So if you want to bring up my screen.
I can do that. All right, so we have your screen up.
Okay, so the first thing we knew about was the fact that there are, I have them listed here, there are 4 socket connections that you can make to a drone. One is on port 554
okay.
Over UDP, and I'll talk about what each of these does in a second. 5555, 5556, and 5559. So we knew these 4 ports existed. The 5554 is the one that you get information back from the drone using. So it will actually send over UDP. It will send you messages regarding its altitude, its velocity, its battery levels, all sorts of information that you can actually just get straight back from this thing. Because this thing's got really a lot of sensors on it. It actually gathers a lot of information for you. So that's how you get that back. So you get packets on 5554. 5555 is its TCP channel where it actually streams across H.264 video.
Okay.
So again, you can connect up to that. As soon as you connect to it, it starts sending you video information. Now we actually haven't implemented, I should say about this code, not only is it on the GitHub samples, but it is not, should we say, a fully fledged covers all angles API. Certainly it was more of a, as you said, we did this at the hackathon, it was a proof of concept. We wanted to actually see how easy it was to get the communication up and running and get the thing flying, but it's not, as I say, it's not a replacement for anything that the I've currently got, which is mobile apps. So 5555 is the video.
Yep.
5556 is what I consider to be a really interesting one. This is actually how you send commands to the drone. Now the drone itself abstracts away quite a lot of, well, an awful lot of the hard work, judging from what I understand about flying other remote control vehicles. So for example, one of the AT commands, an AT command actually used to be used when you were talking to old school modems. So you'd actually send AT commands, which are just string commands. And so you send the drone AT commands, and one of which will be take off, and it will just take off and hover, waiting for you. Another one is land. And we'll step through some of these in a little more detail. So you actually construct all these AT commands per frame that you want to send to the drone.
Yep.
And then the last one is the command one, which you can see at the bottom of my screen, which is on 5559. And I'll just scroll there. 5559, and that is used for sort of admin controls, admin commands that you need to send, just because you're potentially sending an awful lot of information, as I understand it anyway, over the AT command on 5556. There's a chance that you could be losing packets because this is over UDP rather than TCP. So if you're not familiar with the differences, basically TCP is guaranteed delivery, UDP is not. So we send a lot, and so there's a possibility that certain command packets could get lost. So the command one at the bottom there, that 5559, is like a separate channel on which to have a discussion with the drone and say certain things like emergency cutouts, I believe, are on that channel, which you kind of want, really, if it's going to be an emergency. Okay, doke. So those are the 4 sockets that we need. And if we go down, you'll see that I've got an init in the API, and init connects 3 of the 4. As I say, we haven't done the video one. It connects up the AT, the nav, and the command sockets, and that looks a little bit like this. So you can see we've got chrome.socket.create, and in those objects that I had, we've either got UDP or TCP, which is the first parameter, an unused second parameter, and then the callback function. Don't forget that all the Chrome APIs are asynchronous. That sends you back a sock info, which tells you things like the socket ID of the socket that you just created, and that then allows you to do connects and bind. So again, it's one of these things. It's worth looking at the socket documentation, and it's worth spending a bit of time understanding socket communication in general. But we have different things like bind and connect. So we do depending on what it is we need. So for example, when we bind a socket, that's normally when we want to receive information. When we connect, it's typically where we want to send out. It's not entirely the same. So there are subtleties to this. So what we do is we go through, we create those sockets, and you'll see when we do that, we just have a little callback that says when we're connected. If we've got nothing left to connect, then we start actually communicating with the drone, which is always nice. So we send a keep alive command roughly every second, which basically says to the drone, I'm here, I'm here, I'm here. If you don't do that, after 2 seconds, the drone determines that you are no longer around, and I think it goes into hover mode, waiting for you to actually reconnect. So it's good to send those keep alives. Okay. Flat trim, that says, because this is the first thing we do before we take off, we say to the drone, you're on horizontal ground, so you need to calibrate as though this was flat ground, because one of the many things it does is it keeps itself level. So the flat trim is used for that, to actually work out what level and medium is, I suppose. Sensitivity, I actually have you can set the sensitivity, so when you're actually flying this thing, how sensitive it is. I actually have it set quite sensitive, which may explain how difficult I made it for you to fly, Pete.
Well, I wasn't that bad. It was more the, I don't know, the first couple of times I think we were trying this, it was kind of fun because I think for both you and I, we were trying it for the first time. We had never done it before, and we were going on this sucker in a kind of slightly windy situation. So we were
Yes.
we were in an interesting place where, hey, we're outside, because we didn't want to try it inside, because when we did try it inside, we ended up hitting a few walls. Oops. And then a few times once we got outside, it was good, but we ended up having people running around, so it made for a kind of fun time.
It certainly did.
Yeah.
So this is all by way of Bootstrap at this point. So we've opened up our socket connections. We've sent a few commands, and I can dig into those commands in a second. But the main thing to know is we then go into this loop, and this is the bit that's the sort of the heart and soul of what's going on. So let me drop down to loop. Where is he now? Loop. Okay, so you'll see that we've got these drone commands, and I'll show you what one of those actually is. The first parameter is the actual command. Now, if you look inside the documentation, you'll see that typically the commands are like AT star and then a specific command, and one of those specific commands is this PCMD_mag. And then it's normally a comma-separated list of parameters after, which actually are what you're configuring. So in this case, the PCMD mag is for telling the drone how to fly. So it's left and right tilt. So there's a thing. If you're looking at the drone, it's got left and right tilt, front and back tilt, which is it actually flying. Then there's vertical speed, which is kind of up and down its elevation, and then there's rotation, the angular speed. So you can see all four of those things are actually captured here.
Right. Now,
okay.
The one thing, and you probably are going to go into this in a sec, but I saw that float 32 to int 32, and I'm like,
yeah.
Okay, why the heck would you convert a float to an int, and why are you doing it yourself instead of just using, you know, one of the built-in functions? Like, why not just do floor or ceiling or, you know, something like that where we can get a much more manageable value?
Okay, so for whatever reason, the drone likes to receive float values as integers. So that doesn't mean, so if say for example the left and right tilt, so that's the sort of flying left and right, you get a number between -1 and 1. That's what you've got to send the drone. But bitwise, that comes out as a completely different number as an integer. So the actual bits for a 32-bit float that make up -1 look very different to the bits that would make up an integer at -1, as I understand it. So we wrote the util, so drone.util float 32 to int 32, which converts at the bit level. And what we do, this is actually very useful if you ever need to do it. The array buffer is your best friend here. So we create a 4-byte, so that's 32 bits. We create a 4-byte array buffer.
Yep. And
then a data view on that buffer. And then we set a 32-bit float on our buffer with the value, and then we read back out an integer 32. So it's definitely worth looking into data views and array buffers if you've never come across them. The array buffer is it's almost data agnostic. It doesn't really care. It's just going to store bits and bytes. It doesn't really mind.
Yep.
It's the views that you attach on the top. So data view is good when you need to push in and pull out data of different types, like unsigned integers, floats. Some of them 16-bit, 8-bit, 32-bit. So it gives you all these different ways of actually accessing the underlying bits and bytes. So that's how we actually do that conversion from a 32-bit float to a 32-bit integer. So that's why. It's just simply because that's how the drone likes to receive its data. How it then actually deals with it on the other side, I'm not so sure. So one of the things we're doing is we've got these numbers that we're converting, the left and right tilt, the front and back, the vertical speed and the angular speed, and we're converting those, or wrapping them up in a drone command. So let me show you a drone command, which is remarkably simple. We create a command with the actual command string, which in that case was PCMD_mag, and then the parts, the actual parts of the message that we want to put after the command, so the actual values themselves. So you'll see in this case, this has 1, 2, 3, 4, 5, 6, 7. I'm not using 6 and 7, as you can see. I've just filled them with zeros for now.
Yep.
And then, whenever we actually write it out to a string, you'll see I mentioned at the start we have this AT* followed by the command.
Right.
And that's exactly what we're doing here. When we say, give me this drone command in a string format, it converts it. It says AT* followed by the actual command.
Okay.
And then you'll see this drone.sequence.next. Every message that you send to the drone is incrementally, increases by 1 every time. That's a better way of saying it. So we start off at 1. The first command you send has a sequence number of 1, and it just goes up from there. So we just keep a track on that internally, so you don't have to, remember which number you're on and so forth. And then we just simply join together with commas the different parts of the command.
Okay.
Okay.
Cool. So I just want to interrupt for 1 sec. As people are watching this, if you have questions, you can go post your questions to the Google Moderator Queue. If you go to http://goo.gl/G, small g, capital H, capital C, G, and that's a small g, and H. I'll get that posted on screen here in a sec, but again, that's small g, capital H, capital C, small g, capital H.
Awesome. So we've got this command that actually tells the drone where to fly and so forth, but for the eagle-eyed among you, you'll have realized we've not actually told the drone to take off. Luckily, that's the next one. And that simply just takes a number. So the command here is ref, and it takes a number. There are 2 numbers, take off and land. And they're just stored internally, I believe, up in the constants up here. I have take off and land. It's 2 magic numbers. So, let me see now. Take off and land. So it's interesting then that you're in this situation where, it's also worth saying these numbers are absolute values. So one of the things about sending these packets repeatedly to the drone is you might be thinking, well, what if packets get dropped? Like how's it going to, how's it going to cope with that? So there's a couple of things here. One is that we loop about every 30 milliseconds, and again, the SDK sort of recommends roughly that rate, that you send these commands, roughly that often. But these values are absolute. So, for example, the tilt is a value between -1 and 1. The drone seemingly doesn't expect you to interpolate between numbers or anything like that. If you say 0, it's just going to stop there. If you say -1, it's going to go off, and as soon as you say 0 again, it's going to stop. So it's not like you have to manage the transition between those numbers. So in that sense, we're sending more than enough packets to just get through to the drone to say, here's how I want you to behave right now. And certainly in our experience, it's worked out just fine. Okay.
All right.
And then let's look at the actual actions. So we expose through this API a number of actions that you can actually do. Take off, land, raise and lower the drone, tilt left and right, which we talked about. So there's the flying ones, the tilting ones, then there's rotation, and then there's an all stop, which basically just resets all those values to 0. And you can see they're all set on this status object, which we use when we're actually pulling out those values. So we have this sort of single source of truth internally to the API as to what we think the drone should be doing. Okay?
All right.
All right, so these all get exposed, and that's really all there is to it in terms of actually sending out information. We do pick up the nav data. Let me just find that. Now I don't pick it up all that often. It's something of a to-do of mine is to actually pull in more nav data and potentially use it to visualize what's going on a little bit more. But what we do is we read from that nav socket, and if you remember back at the start I said 5554 is the socket on which the drone's going to send its information to you. So we read from that, and if we have data, we just run it through this drone.navdata.parse. So this just comes back as an array buffer, and it contains some data. And the data it contains, as I said, is things like, well, you can see here, we get things like the battery percentage, its angles, its altitude, and its velocities. And what we do is this array buffer that comes back in through the socket, we attach, you'll find here, and one of those data views again onto that data so that we can start pulling things out. And then at very known positions from within that array buffer, we can start pulling numbers.
Okay.
So the battery is, for example, I think at the 24th byte or thereabouts, maybe slightly further on. So as I say, the documentation has all this listed for you, as does the source code. So it's more a case of fleshing out and saying, okay, I get this data back from the drone. It's just this raw data. Now I actually need to specifically attach on a data view and sort of pull the numbers out manually. And then obviously we wrap those back up as an object and return those if needed. So you might think it's actually more complicated to talk to a drone. It's actually not. Chrome does a great job of abstracting away the socket read and write stuff that you need to do. So it's really just a case of opening the socket, follow the instructions, and start reading and writing data. So then the other side of this, unless you've got any questions, Pete?
No, I'll let you keep going, yeah.
All right, cool. So we had this, now got this drone API, and we wanted to wrap it up inside a Chrome app and put the Gamepad API on it and so forth. So one of the first things I did was to get one of these.
Right, so the Gamepad controller.
Yep, and drop that into Chrome. And then on HTML5 Rocks, and we can put this link up in a little bit, we have this tutorials on the Gamepad, because one of the things about the Gamepad API is it's Gamepad agnostic, and that means it can be quite interesting to work with because it doesn't say, oh, this is the X button or the square button. It just says this is button 1 or button 2, button 3, button 4. So when you actually know the pad you're dealing with, often it can be good to abstract that away a little bit. And that's exactly what this code does. And it's on HTML5 Rocks. And it's definitely worth reading through because it's a really good introduction to the Gamepad API. But you'll see right at the bottom of here, I've wired it up so that I have this drone.gamepad. So I abstracted the Gamepad a little bit further and have this update button and update axis. So every button on the Gamepad and every axis for the sticks, sticks over here, they get sent through to me.
So you're listening
through this
for each
update
of those.
button, and yeah, this is actually, it's done through polling. So there aren't events for the Gamepad API. It's a polling API. So yeah, you sort of request from the Gamepad, okay, button 1 or button 0, what's its current status? So that gets sent through. Now that, curiously enough, actually fits with our model because we're going to be sending data to the drone very often as well.
Yep.
We know we're polling the Gamepad. We get the latest value from the Gamepad, and we send that through to the drone. We pipe it through the API, but we send that through to the drone. So let me just fire up. I believe it should be in the drone's Gamepad API. So you can see in the update button and update axis, we have a little bit going on. Let's talk about the update button. So, update button, that gets called whenever I press, or in fact it gets called several times a second. All I'm looking for is whether the value is 1, so press down. Now if it's the right shoulder button, you'll see I'm calling telling the drone to take off. If it's the left shoulder button, land, and the select button on here is the all stop. It's the one that actually says to all the numbers, go back to 0.
So one of the things that, as you were talking about this and telling me about this originally, the question I had is, so are you using request animation frame to do these loops, or are you doing a set timeout? So
we are using set timeout because request animation frame would drop to 1 frame per second if the tab or window wasn't actually focused. In the Chrome apps situation, it's possibly slightly different. I would need to double check, but we really want that data to be sent in any case, and it's not visual updates that we're doing to the browser. So it's probably a suitable situation in which to use set timeout. And I think at the bottom of the loop there, you'll see set timeout is what we're doing for making sure that we call loop whether or not we're actually minimized, maximized, or the app's on view on screen.
Yeah.
Back to the gamepad. One of the interesting things about the update axis, so the values here on the axes are -1 to 1 in both the axes, which maps extraordinarily well to our drone, which takes values of -1 to 1. So pretty much all we do is we take whatever the value is on that particular axis, and you'll see if it's stick 1, which is the left one, we just pass it tilt left and right until front to back. Stick 2 is going to be used for rotation and raise and lower, and that's it. That's all that's involved with the Gamepad API. So there you go. That is pretty much it. Everything else is just icing on the cake in terms of actually putting together a standard Chrome app. What I should say, I have missed something, which is the permissions side of things.
Okay.
Socket permissions are required if you're going to actually open and use socket connections. So I've got UDP bind, send to, and TCP connect listen. Those are all documented on the developer.chrome.com/apps site, and you can actually have a look and see what permissions you would need if you were going to build something like this. So don't forget to add those socket permissions to your manifest if that's what you're doing. Okay?
All right, cool. Well, we seem to have a few questions coming in, so let's pop over to some of those questions and see what we can do. So the first question is, what's the latency in milliseconds for controlling and getting the sensor data from the drone? Is it similar to the Parrot app on smartphones, or is it worse? What was your experience on that?
So we haven't actually tested this comparatively or anything, but what we have done is we've made those APIs, the socket APIs, are quite close to the metal, so they're really quite performant and really fast. Yeah. And certainly I've had no problems getting messages through to the drone or getting messages back from the drone. Right. So while that's empirical, it's certainly what I can certainly say for sure that it's been no problem to work with.
Okay. And so we do know that it's not going to probably be like instantaneous, but it should be pretty quick, and we can see how things go. That's maybe something we can have a look at and add to the documentation or something like that.
It is worth bearing in mind that the drone creates its own Wi-Fi network. I'm not sure if I said this at the start. It creates its own Wi-Fi network when you switch it on.
Oh, interesting. That's right. So it's not connecting to sort of your your personal Wi-Fi network or anything like that, which would be really cool, because it would mean like, here at work we could connect it to the Google wireless. I could be at one end of the building, or I could have it here and you could fly it in London.
I'm terrified of you having a drone army, remote drone army. That's the stuff of nightmares.
Yeah, it would be kind of fun though, I gotta say.
Yeah, it would. So because of that, it's not going through any routers or switches. I mean, I'm no networking hardware expert, but that certainly it gives you every chance.
Cool.
Sure.
And you do have those multiple channels, so that way you can get stuff back. If you're sending a bunch of commands out to one, you've got that emergency channel that you can get something in. Obviously, it's not going to be perfect for getting the stuff back, but at least gives you a well thought out API that you can play with.
Definitely. I mean, this is UDP. Like I said, UDP is not a guaranteed delivery by the very nature of the protocol. But there is a lot of traffic. So the other thing to say is all the messages back from the drone are sequenced. So if you did manage to get something out of order, you can always check the sequence number and make sure it's greater than the last one you received.
Oh, perfect.
Which is much as you're sending an increasing sequence number, so is the drone. They don't relate, but they both go up over time.
Okay, cool. So Devin wanted to know how he could get started with Chrome apps or get pointed in the right direction. And Devin, I think that's a great question, and there's a lot of good resources, and watching events like this is certainly one place as we dive into a bunch of the APIs and some of the things that you can do. But the best place you can go is to the Chrome developer documentation. So if you go to developer.chrome.com, and have a look on the right-hand side, there's a link there that says Chrome Apps. Click that. There's some really great stuff on how to get started. The other good one that's really interesting and really useful is to check out the I.O. talk that was done by Eric and Mihai, two of the engineers on Chrome Apps. So if you go to google.com/IO and look for the session that they did, Eric, Kai, Mihai, and I'm going to mispronounce his last name, but it starts with a P. And
I'm leaving you hanging here. I don't know how to pronounce Mihai's surname either, I'm afraid.
Awesome. All right.
The other thing, Devin, is it's worth watching previous sessions that we've run. The first couple of weeks in particular, we talked about the Hello World, and what the APIs are, and CSP, content security policy, and all those kinds of things. So definitely worth watching those as well if you have time.
Yeah, so and you can find those all if you go to developers.google.com/live and look at the Chrome events. We've done now, I think this is our 5th or 6th Hangout that we've done, and we're doing them as a weekly event. So next week we'll do a different topic, we'll dive into some new stuff, show you guys some pretty neat things that are going on. So the next question, I think, Paul, this one's pretty much for you. What Sublime theme are you using?
It's Soda Dark, and it's Monakai as the color themes. I had to double check that just then. I wasn't sure. It's been a while since I changed it, but yeah, it's Soda Dark, and and it's Monakai as the color scheme.
Yeah.
Okay.
So now you've taken this code, you've put this code up on GitHub, is that right?
Yeah, so it's github.com/Google Chrome/Chrome-app-samples.
Samples.
So we talked about this over the last few weeks. It's the normal GitHub repo that we mention each week. So take a look at that. It's under there as Parrot AR Drone.
Okay.
And there's the README. The code is commented. As I said, it's not going to cover every angle, but if you want to see about how you can get started with socket programming, it should be one of several good examples.
Yeah. Yeah, it's a good, easy way to sort of look at some of those things. There's lots of devices out there that do have IP and socket-based stuff. In that set of samples, there's ones that'll do, I think there's a Telnet one, if I'm not mistaken, and there's a couple others so that you can go and play with those kinds of things. And there are other hardware devices that you can pick up. The one that I've been playing with recently, because I want to figure out a way to control my air conditioners. I've got a window air conditioner here in New York City, and it gets a little hot, and I forget to turn it off. Got my first electric bill the other day, and oh yeah, don't forget to turn your expensive appliances off, because yeah, they not pretty. In any event, I want a Chrome app that'll allow me to turn this on and off. And so there's a IP to infrared controller that I found that'll allow me to go and do that kind of stuff. So that's just another example of some of the hardware control that you can do with Chrome apps. So with that, I think that's about the end of our questions for this week. We're going to be back next week with the Pauls, with Renato, myself, and we're going to be diving into some more stuff about Chrome apps. So with that, thanks everybody. Hope you have a wonderful week, and we'll talk to you all soon.
Thanks.
Alrighty. Bye everybody.
Bye.